questions 1 through 10 on the 2018 grade 12 AMC 12A. A large urn contains 100 balls, of which 36% are red and the rest are blue. How many of the blue balls must be removed so that the percentage of red balls in the urn will be 72%? No red balls are to be removed. We have 100 balls in total. 36 are red, and therefore the other 64 are blue. So we want to remove a few of these. So let's say we remove X. Once we do, there will be 64 minus X blue balls remaining. So the percentage of the red balls would therefore be 36 over the total, which would be 36 plus 64 minus X. And we want that to be 72%. So that would be 0.72. So now you just cross multiply. So 36 over 0.72 is going to be 100 minus X. And this looks like 50. 100 minus X. And therefore X is 100 minus 50, which is 50. So you have to remove 50 of those blue balls so that the percentage of red balls in the urn is 72%. So number 1, the answer is D. While exploring a cave, Carl comes across a collection of 5-pound rocks worth $14 each, 4-pound rocks worth $11 each, and 1-pound rocks worth $2 each. There are at least 20 of each size. He can carry at most 18 pounds. What is the maximum value in dollars of the rocks he can carry out of the cave? So 5-pound, 4-pound, and 1 pound, $14. We got $11 and we have $2. And all of these have, there's 20 of all of them. Okay, let's see what kind of scenarios. We can't have 4 of the 5-pound rocks because he can only carry 18 pounds. So 4 would be 20 pounds. So that's not possible, but we can have 3 of them. So 3 of those would be 15 pounds, and then I guess the only way is 1, 1, and 1. So this would be $14, $14, $14, $2, $2, $2. And when you add up these guys, you get 42 plus 6, which is $48. Okay, that's one of the answer choices, but let's see if we can get anything bigger. 5, 5, because I can't have 4, but I can have 3 or 2. And then I think 4 and 4. 4-pound rock and 4-pound rock. So $14, $14, $11, $11. And when you add up these guys, you get 50. Now let's try just one 5-pound rock. 4-pound, 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 and that brings me up to 17 1-pound. 14, 11, 11, 11, and 2. That's going to be 33, 47, 49. And you can keep going like that. So the point I'm trying to make is that when you look at all these scenarios, you will clearly see that the one that's greatest is the 50 pounds. Now, $50, I should say. So number 2, the answer is C. How many ways can a student schedule 3 math courses, algebra, geometry, and number theory, in a 6-period day if no 2 math courses can be taken in consecutive periods? All right, 1, 2, 3, 4, 5, 6. So period 1, 2, 3, 4, 5, and 6. I can have algebra here, geometry here, and number theory here. I can have algebra, number theory, and geometry like that. I can have algebra, geometry, and number theory in those spots, or I can flip the number theory and geometry. And then I can also have algebra, geometry in the 4th period, number theory in the 6th period, flip the G and N. And then I can move algebra to the 2nd period, and then G and N would go in 4 and 6, or you can flip them like this. So as you can see, I just created 8 scenarios. But all of those 8 had A as the leading course. I can do the same thing for G as the leading course and N as the leading course. So therefore, this 8, there would be 8 with A as the leading course, 8 with G as the leading course, and 8 with N as the leading course. And therefore, the total would be 24. So number 3, the answer is E. Alice, Bob, and Charlie were on a hike and were wondering how far away the nearest town was. When Alice said, "We are at least 6 miles away," Bob replied, "We are at most 5 miles away." Charlie then remarked, "Actually, the nearest town is at most 4 miles away." It turned out that none of the 3 statements were true. Let D be the distance in miles to the nearest town. Which of the following intervals is the set of all possible values of D? Well, the 3 statements mathematically are written as D is greater than or equal to 6, D is less than or equal to 5, and D is less than or equal to 4. Now they're saying that none of those statements are true. So that means that D must be less than 6. This one is not true, so D must be greater than 5. And this is not true, so D must be greater than 4. So if we have a number line, 4, 5, and 6, D is less than 6, okay. D is greater than 5, okay, and D is greater than 4. So these 3 on a number line would basically be the values between 5 and 6, as you can clearly see. So number 4, the answer would be D. What is the sum of all possible values of k for which the polynomials x squared minus 3x plus 2 and x squared minus 5x plus k have a root in common? So we have x squared minus 3x plus 2 and x squared plus minus 5k minus 5x plus k. And they have a root in common, so we can set them equal to each other. And let's see what we get. The x squared cancels, and I get 2x is equal to k minus 2. So that means x is equal to k minus 2 over 2. So let's substitute that in to this equation. So we have k minus 2 over 2 all squared minus 5 times k minus 2 over 2 plus k is equal to 0. We'll set it equal to 0. So expand this and you get a k squared minus 4k plus 4 over 4 minus 5k minus 10 all over 2 plus k. Multiply through by 4, and that will give me k squared minus 4k plus 4. And if you multiply through by 4, that top becomes minus 10k plus 20 plus k. Let's collect like terms, and when you do, you get k squared, and let's see here, minus 10k plus 24. And I think this will factor. It will be k, 8, and 6 and 4 actually. 6 and 4. That would do it, minus. So that means k is equal to 6 and 4, and therefore the sum of the possible values of k is going to be 6 plus 4, which is 10. So number 5, the answer is E. For positive integers m and n such that m plus n is less than n plus 1, both the mean and the median of the set are equal to n. What is m plus n? So here's our set. The mean would be adding them all up and dividing by 6. So that would be 3m plus 14 plus 1, 2, 3, 4n plus 3 dividing by 6. And they're saying that's equal to n. So that means 3m plus 4n plus 17 is equal to 6n. And therefore 3m plus 17 is equal to 2n. And the other one is the median. That would be the average of the middle guys. So m plus 10 plus n plus 1 divided by 2 is equal to n. They're saying that is also equal to n. So m plus n plus 11 is equal to 2n, and therefore m plus 11 is equal to n. Substitute that into here, and when you do, you get 3m plus 17 is equal to 2 times m plus 11. 3m plus 17 is equal to 2m plus 22, and therefore m is equal to 5. Substitute that into here, and n is equal to 16, and therefore m plus n would be 5 plus 16, and that is 21. So number 6, the answer is B. For how many not necessarily positive integer values of n is the value of 4,000 times 2 over 5 to the power of n an integer? 4,000 times 2 over 5 to the power of n. So 4,000 is 2 to the power of 5 times 5 to the power of 3. That's the prime factors. And then 2 to the power of n, 5 to the power of negative n. Let's combine them. 2 to the power of 5 plus n, 5 to the power of 3 minus n. For this to be an integer, 5 plus n, this exponent right here, has to be greater than or equal to 0. If it's less than 0, it would go in the denominator and it would become a fraction. And in a very similar way, that exponent, 3 minus n, also has to be greater than or equal to 0. So that means n is greater than or equal to negative 5, or n is less than 3. So n, combining these, is less than 3, but greater than negative 5. And n is an integer itself, so that means 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, and negative 5. Those are the possible values. So 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Number 7, the answer is E. All of the triangles in the diagram below are similar to isosceles triangle ABC, in which AB is equal to AC. Each of the 7 smallest triangles has area 1, and triangle ABC has an area of 40. What is the area of trapezoid DBCE? DBCE would basically be equivalent to the entire triangle. Subtract from it, I'll just label this F and G. So that triangle, AFG, which is the top guy, I guess, this one. And then subtract from that the trapezoid FGDE. Well, the good news is ABC, that they told you is 40. AFG, that is something we don't know yet. But FGDE, those are 7 small triangles, each of which has an area of 1. So that means that FGDE would have an area of 7. So this just boils down to 33 minus AFG. So if I can figure out AFG, I will be done with the question. So let's concentrate on that. And I think similar triangles will be how we're going to do this. Draw a line from A down to the bottom, and draw a line there in that small triangle. I'll call this big H, I'll call this small h, I'll call this small b, and I'll call this base big B. So H over big B, a big H over big B, is the equivalent of small h over small b. Now, one thing I hope you can immediately notice is that big B is the equivalent of 3 of those small b's. So big B is equal to 3 small b. So that means h over 3b is equal to h over b. So h over 3 is equal to small h over 1, and therefore h is equal to 3 of the small h. Okay, now we can figure out the area of AFG. AFG would be 1/2 base times height. big B times big H. That's 1/2. Big B is 3B. Big H, we just calculated, was 3 small h. So this becomes 9 times 1/2 BH. And this is the area of one of those small triangles, 1/2 small b times small h. And they told me that is 1. So this becomes 9 times 1, which is of course 9. So AFG is equal to 9. So coming back to here, it would be 33 minus 9, which is 24. So number 8, the answer is E. Which of the following describes the largest subset of values of y within the closed interval 0, pi, for which sine x plus y is less than or equal to sine x plus sine y for every x between 0 and pi inclusive? Sine of x plus y is less than or equal to sine of x plus the sine of y. Put everything on one side, but before we do, let's use the trig identity to expand that. And I hope some of you remember, it would be sine of x cos of y plus the cos of x sine of y. And let's bring everything else over, sine of x minus sine of y, and that's less than or equal to 0. Now we can factor sine of x, and it would be cos of y minus 1. And we can also factor out a sine of y, and it would be cos of x minus 1. Okay, so let's discuss this now. The cos of anything is between 1 and negative 1. So if I subtract 1, it would become cos of x minus 1. It's between 0 and negative 2. So this and this are less than or equal to 0. So let's put that in there, less than or equal to 0, regardless of what x is. They're always going to be less than or equal to 0. So if we want this whole thing to be less than or equal to 0, then that means this must be positive and this must be positive. Because if that was negative and negative, you would get a positive and a positive, and then that would be positive. But we want the whole thing to be negative. Well, now our question really is, when is this guy positive? For what values of y? And our range for y is between 0 and pi. Well, if we draw a quick graph, some of you remember for the sine function, like that, and where this is 0 and this is pi, the graph of sine of anything is always going to be positive. As you can see, it's always above the x-axis. So this sine of y right here will indeed be positive, always positive for y in that range between 0 and pi. And that's it, really. It doesn't really matter, I guess, if you put greater than or equal to. And that's it, really. So the answer is the entire range between 0 and pi. This will be valid. So number 9, the answer is E. How many ordered pairs of real numbers x, y satisfy the following system of equations? X plus 3y is 3, and the absolute value of x minus the absolute value of y is equal to 1. So, as always, in these kinds of questions, we've got 4 different scenarios, right? The first one is when we have this scenario of x greater than 0 or y greater than 0. Now, from this guy right here, I can isolate pretty much that x is equal to 3 minus 3y. So what it really boils down to is really just 3 minus 3y is greater than or equal to 0, and y is greater than or equal to 0. The other one is 3 minus 3y is, say, less than 0, but y is greater than or equal to 0. The other one, you just flip those. So 3 minus 3y is greater than or equal to 0, but y is less than 0. And then finally, both of them are less than 0. 3 minus 3y is less than 0, and y is less than 0. And for each of these, we'll calculate this guy. So that means that the absolute value of x minus the absolute value of y is going to be either 1 or minus 1, because that's what would happen if you took the absolute value of the whole thing. As you can see, they took absolute value of the whole thing. So for the first one, looks like we have, since they're both greater than 0, it'll just be 3 minus 3y minus y is equal to 1. So that means 3 minus 4y is equal to 1. And therefore, it looks like y would be equal to 2 over 4, and therefore y is equal to a half. In a very similar way, we do the same thing here, but this time for negative 1, 3 minus 4y would be negative 1. So 4y would be equal to 4, and then y would be equal to 1. So you can easily calculate x by putting it back into there, and when you do, for y equals a half, you get a value of 3 over 2. And then for y equals 1, you get a value of 0 for x. So those are our two pairs. So you do the same kind of thing for everything else. And since this is pretty straightforward, I'll just do it without walking you through it. So for the next one, this one right here, we're going to get 3y minus 3 minus y. Remember, this flips because it's less than 0 this time. And that equals 1. And this will give me y is equal to 2. And then if I do the 3y minus 3 minus y is equal to negative 1, that's going to give me y is equal to 1. So as before, substitute back into here to get the x values, and when you do, you get minus 3, 2, and 0, 1 again. Okay, well, let's do the other guys. This one would be 3y minus 3 minus y this time is equal to 1, and that's going to give me y is equal to 1. And then the other guy would be 3 minus 3y minus y is equal to negative 1, and that's going to give me y is equal to positive 2. And substituting back, you get the following values. You get 0, 1 again, and you get the minus 3, 2. And then finally, the last one, when you have them both being less than 0, we get 3y minus 3 minus y is equal to 1. That's going to give me y is equal to 1. And then the last one, it's just going to be 4y minus 3 is equal to negative 1. And that's going to give me y is equal to half. So this guy would be 0, 1 when you find out the x values, and 3 over 2, 1 half. So now we have to find the unique pairs. So we've got 1 here, 2, 3. This is a repeat, this is a repeat, this is a repeat, this is a repeat, this is a repeat. So only 3 unique pairs. So therefore, number 12, the answer is C.